tanks for the CARF Su30, and here's what comes with the tank pack. Comes in a little baggie like that, with some Velcro and some mounting pieces of wood for the UATs, hardware for the UATs, hardware for the tanks, and some fuel line for you to use. So I personally will probably be using this guy externally, but instead of doing Tygon, I'm gonna go and get some Viton tubing, just better for maintainability. But with that, I'm gonna set up these fuel clunks and intakes, and then we'll go from there. The clunk and the intake lines, and you can see, well, I guess it's not as obvious, but these are measured to be as exactly close as I can possibly get them. And the reason for that is I'm thinking I might run these in parallel as opposed to series, just because these tanks are very long, and if I did a series, that would mean you have to pull a vacuum in here and then in here before you can get the fuel. So I'm not sure if that'll work well, but in parallel it should probably work, and I think that's what the CARF manual also recommends. So key things here is everything is tie wrapped, and I'm using this piano wire, which is 0.020 gauge and 1/4 pound weight. Nothing crazy. And then the other thing to note is when you tie wrap these, if the connection has a barb, you kind of want to go put that as close to the barb as possible, as you can see in that case and in this case. That way it grabs almost instantaneously if that is trying to get pulled out. So the next thing we'll work on is show you what this means for the tanks, and then we'll move on. Here's a tank, and I've tried to simulate this being where it would normally attach to in the tank, and then try to show you where the length should end. So right in here, I'm not sure if it's visible, but there's some epoxy right around here. You can see the color difference. There's a baffle, and so what happens is, what I decided to do is put the brass pipe right in there, because what the baffle does, I can show you in the tank here, you see that piece of fiberglass in the middle there? It's a piece of structure that will prevent the pipe from the line here from kinking on itself, but also because the whole thing has to go in through there, it needs to be supported there. So that's why I kind of try to have this brass tube, the middle of it be right around where the baffle is going to be. And then in terms of length, you can see that when the fuel intake is in there, the clunk ends just about here, but the important part is to make sure that when it's on the top side, it gets as far back in the tank as possible without giving it a chance to get caught in there. So in fact, this I might shorten just a little bit, because it's possible that, you know, it could get stuck up there, but essentially you want it so that when this is lifted up, it's right at the end but not quite hitting the tip, and it can drop down so that the clunk can move up and down as it needs to. So I have trimmed the fuel line, and now you can see in the shadow in there that it is perfectly lengthened to what I expect. So with the clunk all the way in the top side of the tank, it barely touches the back, and then it can drop down real nice. So that's great. I'll give you the measurements for what I wound up with, and we can move on. So my fuel line ends up being around 13, right around 13.25 inches, just a bit shy, maybe. Yeah, so you can see where that ends, and roughly that's the length that I ended up with. Stage is just screwing the vent fittings in place, and we're done. So next thing I'm going to do is pressure test the tank and make sure that there's no leaks, and I'm going to do that by basically putting in some fuel tubing into both of these, sealing one off, putting air into one, sealing that off, and then seeing if when I dunk this in a bucket of water, air bubbles come out. And if not, we're good to go, and it's time to install them in the jet. We're getting ready to test, and I just made some end plugs. I thought I had some, but anyways, with that style of a T, and you block both ends, and that way I can blow in through one of the spots, close it, and check for pressure leaks. CARF quality, not a single bubble in sight. Look at that. So that's the first half of the tank. We're gonna flip it over. Let's check the other side, the other half. Not a single bubble in sight. And for the final spot, you want to hear that air come out. Let's see if I can do this one here. It's going to be tough. There we go. Tank's good. Other tank. On the way to secure the tanks, and basically the kit comes with these aluminum pieces, and those, per the manual, are going to be glued sort of like that to the tank. And then you have this setup which comes in your kit, your Kevlar tank kit, and basically because goes something like that. And then that way, when you put this, you have enough depth there to actually screw that into here. And that's how the tanks are going to get held inside the jet. So basically, we're going to start the process. Actually, I guess this guy goes in like that. So you put that, assemble this way, and then that way, you glue that sandwich into the fuselage, and then the aluminum bits you drill obviously the hole through, and that's gonna sit. Drill there, and then for the second tank, same way. So we'll do that and show when it's all done. So here's a sandwich, and I'm using Type Bond 3 because these are all wood joints. We're gonna let that sit for 24 hours, and then we'll do the fitment in the jet. So here we have the mounting system for the tank. So essentially what's gonna happen is, I'm showing just one tank here, but this is a piece of wood that we prepared yesterday with the blind nuts glued together, and it's been 24 hours now, so the Type Bond has cured. And basically, we're going to want a situation like that, whereby this piece of wood is stuck to the fuselage on the bottom, and then the aluminum is stuck to the tank, so that it holds the tank in place. I have added some texture there so that the epoxy is something to stick on. We'll also, once we have put this in a plane, mark around there, and just add a little bit of texture here, not enough to get through to the fiberglass, but just enough to get the epoxy somewhere to stick. The second tank's gonna sit somewhere in here, so we'll put that in the plane, and then we will go ahead and get it all glued down. So here's what things look like inside. You can see sort of where the tanks are supposed to sit. So I'm gonna add a piece of foam in between the tanks. That guy's gonna go in between there, and the reason for that is because we want perfect spacing so that we can mount the Airbrake actuator, which is that guy. That's gonna go in here, and basically if I put these two close like that with no gap, it's not gonna work out. So we're gonna need to put a thin piece of foam in there to get the right spacing, just like that. And then we're gonna push these back, and that might be a bit wide, but I think that should be fine. I'm not worried about making this spacing too wide, because obviously we can always, as long as we have enough gap in between, we're gonna have two things here to support the back of this. As long as we have enough there, that's gonna work. But now what that means is, let's see if we can get that. But now, once those have been placed, we can now position our mount. So I got some wires out of the way, but basically now we see what that setup's gonna be like. So that's seems pretty good, so I'm just gonna mark those positions there, and then we're gonna glue this thing down, and the tanks will be supported like we need them to be. So I seared that board down right there, and I've marked around the tanks, as you can see, with a blue Sharpie, so I know where the aluminum brackets are going to attach and where I need to sand off just a little bit of material and how much. So we're going to go do that and then epoxy this thing in place. So masked out the area, and the goal is here that every bit that I sand I need to fill with epoxy just so that I prevent the tank from leaking. We'll obviously pressure test the tanks after this is done, so we're going to sand this out and then get these guys glued in place. So here we have glued the aluminum brackets to the tanks, and you can see I actually glued these in place. So I set the tank up, make sure everything fit, and then put a epoxy on the back of the aluminum brackets where I had scored, and that's going to attach the tank. And then once this dries, we're going to take the red tape off and put a nice bead around the aluminum brackets again. What we're using up here is this piece of foam, because these tanks, I want to make sure they are pressed down enough so that they actually force the tanks to sit in the position that they would be, and so this foam is helping push the tanks down. The epoxy that we used is E00NS. This dries in about 20 minutes, and then we're gonna follow up with something that is more structurally strong as well. So there is the final resting place of our mounting block. I'm happy with that result. Here's what our tanks look like. Pretty happy with how that came out once that epoxy cures. This is the Loctite E20NS. It's gonna be perfect mounting solution. So now we're gonna mount these and worry about this guy right here. That's the Airbrake actuator. Resting place for the tanks. You can see perfectly screwed down, gap in the middle. So we are working on our Airbrake actuator, and the easiest way to say this is I just did trial and error. Basically, after I mounted my tanks, the next step was figuring out where this goes, and I basically did a couple of trial and errors, mounted that loosely and just close and open the Airbrake and sort of try to figure out where it lands. The CARF manual actually gives you specific measurements, but in addition to that, I also just tried it because I'm using an electronic actuator versus air actuator, which was what was in the manual. So I basically figured out I can glue these two pieces of wood, and then I made these aluminum adapters, basically just an L bracket cut and then shaped this way. And basically what's going to happen is these are going to go sort of like that on the actuator. This side is sort of vertical because that's the side that is the actuator will need to swing on. So let's see. So yeah, you can see that there, just to align with that. So we're gonna let that cure and then we'll go from there. So the Airbrake actuator is mounted, and as you can see, I opted for 4 little screws, 2 on either side of the aluminum brackets that I just showed. Obviously it goes without saying, because these pieces of wood are glued on top of the tank, you got to make sure that the length of the screws doesn't go beyond the wood blocks into the tanks, which I did, and that's working pretty good. So here's my Airbrake. I'm gonna put the PWM values here. So I made it such that it goes between 1100 and 2000 pulse width in microseconds. So here we go. So we can bring that down to just about 1100, and that should close our Airbrake door right around there. So it's nice and a little bit loose, but there's room to tighten this up. So if I go up to 1074, that's nice and tight. It's not coming apart. So when I'm ready to program this in my radio, I'm gonna do that program. Can make that a little bit tight, and then it goes all the way up to about 2000 is where it tops out, which is fine. And it's pretty vertical. Looks pretty vertical to me, so I'm happy with that result. I'm gonna point out is because I want to run these actuators per spec, I have this voltage regulator from Powerbox, so that's gonna step down the 8.4 volts that's coming from my Smoothfly AR20 Pro to 6 volts. That way I'm not overvolting the brushed motor in here, and everything is running to spec.